All right, so good morning or good afternoon again. This is Mr. Koyasu with part 2 of the video. So what we're going to do now is we're going to take what we just learned about the different inequalities and what they represent, and we're actually going to start graphing those inequalities now, those linear inequalities, okay? So let's look at number 1. We have y is greater than or equal to negative 3x plus 4. So the first thing I want to do is I want to identify what kind of line I'm going to have and what type of shading I'm going to have. So what I mean by the line, first of all, is solid or dotted, okay? So looking at this first inequality, I see that it is greater than or equal to, okay? That equal to, if you recall from the last notes, lets me know that I need to have a solid line, okay? And I'll show you what that looks like in a little bit. And then as far as shading goes, again, this is greater than or equal to, so that lets me know that I'm going to be shading above. Okay, this was all in the last notes, so if you don't understand this, go back to the last notes, part 1. Okay, now we can start graphing. Okay, so I'm going to start going about this as if it were a regular equation. Okay, so I'm going to start by graphing my y-intercept, which is positive 4. I'm going to graph that right here. And I'm going to use my slope of negative 3 to go from one point to the next. So I'm going to go down 3 over 1, down 3 over 1, down 3 over 1. Okay? And now it's a solid line. So I'm going to connect all these points as straight as I can with a solid line. Just like that. Okay? So that's what the solid line means. Now, I'm going to be shading above. So I'm going to be shading above that solid line that I just drew. So to do that, I'm going to do something like this. So I'm going to shade above. Again, this part doesn't have to be perfect. You don't have to color it all in. Just kind of make it known that it's shaded. Okay? Go a little more. There we go. Okay. So that's the inequality. That's y is greater than or equal to negative 3x plus 4. That's it right there. Okay? Now what we want to do, the whole purpose of this is I'm going to give you some points, and I'm going to ask you if those points are solutions or not. So I'm going to plot those points in black. So let's plot 1, 1. That's right there. Negative 2, negative 1. That's over here. And then 5, 4. So 5, 4. Okay? Now, if we recall, we learned about the different things that make these solutions, okay? So let's look at the point 1, 1. So the point 1, 1 is right there. It is on the solid line. And if you recall from the first notes, if a point is on a solid line, that means yes, it is a solution. So 1, 1, yes, it checks out. It's good, okay? Now we go to the point negative 2, negative 1. So that was the point over here, okay? That point is not in the shaded, and it's not in the line. So that means the point negative 2, negative 1 is not a solution. So I'm going to say no, X. It is not a solution, okay? And then 5, 4, remember that was the point way up here. That's clearly in the shaded, so that point is clearly a solution. So yes. So 2 out of 3 were solutions for number 1. Okay, let's slide to number 2. So we're going to do the same steps. So number 2, I have the equation y is greater than negative 4. Okay, so first thing I want to do is talk about the line. So solid or dotted. Since this inequality does not have a line underneath, this line is going to be dotted. Okay, and the shading, since it is greater than, it's going to be shading above. Okay, pretty easily. And now what we're going to do is we're going to graph it just like it were regular equations. It's just in case it feels y equals negative 4, okay? So hopefully y'all noticed that if this was a regular equation, this would be a special case. So if I graph y negative 4, that would be down here. Okay, so I'm going to draw a dashed line or a dotted line at y is greater than negative 4, okay? And then we're going to shade above, so I'm going to shade above. So it's a lot of shading there, that whole big area. Okay, just like that. Now we're gonna do the same thing. I'm gonna ask you if these points are solutions. So we gotta plot some points. So I have the point 3, -5. That's down here. -2, -4. And 1, 3. Okay, so same questions. Are they solutions or not? So 3, -5. Remember that was over here. That's plain. It's not on any kind of solid line. It's not in the shading. So this one is no, not a solution. Okay. Now, -2, -4. This one's a little tricky. So -2, -4 is right there. It's on the line, right? But if we remember the notes we took yesterday, even though it's on a dotted line, that means this is not a solution, okay? It's only a solution if it falls on the solid lines, okay? If it falls on the dotted lines, it is not a solution. So this point right here, since it's on the dotted line, not a solution, okay? And then 1, 3. 1, 3 is clearly in the shaded, so that one is yes. That is still a solution, okay? If it's ever clearly in the shaded, it's a solution. Number 3, moving on. We have the equation, or sorry, the inequality. X is less than -5, okay? So we go about it the same way. I forgot to put the shaded, my bad. Shading. There we go. Okay, so based off the inequality, the line I would need, solid or dotted, that's gonna be dotted. There is no equal to line underneath that inequality, okay? And shading, it is going to be less, it's gonna be less than, so I'm gonna shade below, okay? And then we start by graphing it like it was a normal equation. So if this was x equals -5, this would be a vertical line here at -5, right? This would be a vux. But since it's an inequality, I can just graph it like that. And we're gonna shade below. So below, when you have a vertical line, actually means to the left. So I'm gonna shade to the left here. Just like that, okay? So it's just a little sliver. Now we plot some points. So let's plot the point -6, 5. So -6, I go up to 5, right there. Next point, 1, 1, right there. And -5, -3, right there. All right, so let's see if they're solutions or not. So -6, 5, clearly in the shaded, that is a solution. Yes. 1, 1, right here, clearly not in the shaded, or not on anywhere near the line, so this is a no, not a solution. And then -5, 3. -5, ooh, I graphed that wrong. -5, 3 should be up here. My bad, not that one. So -5, 3 up here, okay? That is on a dotted line. So remember, if it is on a dotted line, that is no, not a solution, okay? So that's number 3. Hope you'll have a good grasp so far. We're gonna do 2 more and then we'll wrap it up. So down below, I have 2 more. I have number 5 and number 6, okay? Now, number 5, you might just wanna you think you're on a roll, you might just wanna get into this, right? But number 5, we can't because it is not in like a convenient form that we can graph, okay? So, let me, hold on, we'll pause.